Welcome back to part 3. Here we're going to look at empirical and molecular formulas. In this first problem, we've got a compound that contains 89.35 grams of iron and I forgot a little word there, and 38.399 grams of oxygen. We want to determine its empirical formula. So what we need to do is turn both of these masses into moles. So we're going to take our 89.352 grams of iron, and we're going to have to find iron's molar mass. 1 mole of iron has a molar mass of 845. And this would give us 1.6 moles of iron. All right, let's take a look at the same procedure for oxygen. Oxygen has a smaller molar mass. Whoops, make that oxygen. 1 mole of oxygen is 15.9994 grams. If we do the math here, we should end up right at about 2.4 moles. Let me erase that there. Of oxygen. Alright, so what do we do here? Well, what we're going to do is just divide each number by the least number of moles, and this should give us a 1 to 1.5 mole ratio. For every 1 mole of iron, there's 1.5 moles of oxygen. We don't like that as a subscript here, so to get rid of the 0.5, we're just going to multiply everything by 2. This is going to give us 2, this is going to give us 3, and those are now our subscripts. So our formula would be iron with a subscript of 2 and oxygen with a subscript for 3. That's how you do the empirical formula problem. Molecular formulas are very similar, do the same steps. Here we've got grams of carbon and grams of oxygen or hydrogen. We're going to convert both of them into moles, and then we're going to come up with our molar mass of our empirical formula. We're going to compare it to our molar mass of our molecular formula. So we're going to take 31.23 grams of carbon, convert that to moles. 1 mole of carbon is 12.011 grams of carbon. So if I do this, we should end up with about 2.6 moles of carbon. Trying this for hydrogen, 5.24 grams of hydrogen. Converting this to moles, we're going to divide it by the molar mass of hydrogen, which is 1.00794 grams of hydrogen. This should give us right at about 5.19. So we're going to divide each of these by our smallest number. This is going to give us 1. This is going to give us right about 2. So we've got a 2 to 1 ratio of my carbon to my hydrogen. So it looks like our formula here would be CH2 for our empirical formula. Now what we need to do is turn this into a molar mass. So we've got 1 carbon, we have 2 hydrogens, so our molar mass of the 1 carbon is 12.011. Molar mass of our 2 hydrogens is just going to be 2 times 1.00794. So let's see. Let's just add those together. If we add those together, we end up with 14.027 grams per mole of our empirical formula. How does this compare to our molecular formula's molar mass? So what we're going to do is just take that 84 point, run out of room down here, 2 grams per mole, and we're going to divide it by our 14.02, I think we said 7 grams per mole. And what I end up with, if I do that math, is 6. Well, what does that 6 tell us? So that 6 is going to be how many times more massive our molecular formula or our molecular molar mass is than our empirical formula mass, which means then we're going to have to multiply all of our subscripts in our empirical formula by 6. So 6 times 1 for our carbon would give us 6 carbons. 6 times 2 for our hydrogen would give us 12 hydrogens. And this is our molecular formula.